Okay, my outstanding friends, another shocker du jour, basalt plagioclases. I'm sure you probably have never heard of those before, but they are these little flicky flakes that they find in basalt. They have no idea, it's a mystery. Okay, they call these mystery rock number 2. Well, see that right there? That's plagioclase. Those little white flakes are plagioclase in basalt. And guess what? There they are right there in my microscope, because I have them here as well. And I do know what they are. There is no mystery here at all. Let's just check it out. Okay, I like to start with what the experts have to say, and they're talking about basalt types in Portage Lake volcanics. Well, they think these are all basalts are from volcanoes. It says reading the rocks is a fundamental geological activity. Fundamental, that's the most important thing, is to be able to read the rocks. And it consists of describing very carefully the details shown in a rock and then interpreting the conditions of the formation from those characteristics. Earth history has been illuminated by reading rocks. Well, what if they're reading the wrong way? What if they don't know how to read? Well, that's the case. All right, just remember this. Basalt is mainly made of 2 minerals, plagioclase feldspar and pyroxene. All right, and then they go into basalt is all kinds of different things. It's not just one of this and one of that and one of this. It depends on where it was and what the conditions are when it was preserved. And this is biological. It's not just rocks. All right, this is how to explain this. Porphyrite or porphyritic basalt is characterized by obvious crystals, these like little white and gray crystals. They're usually of plagioclase, often white or tan in color, these good little crystals. These crystals are typically interpreted as phases that formed before the eruptions, where the magma was being stored in a magma chamber. Well, how did they come up with that? On the Isle Royal, there are 5 main examples of porphyritic basalt flows. And they show these different places where they show these different basalts. And they are a lot of different characteristics to them. I'm going to show you some I have right here in the microscope. Okay, my friends. I want to hear from some geologists. That is a rock I have here. I had a CAT scan. This is a rock that I have here, and this has been CAT scanned. It hasn't been CAT scanned, no DNA. That's been CAT scanned and DNA tested. Now this, I'm going to tell you right now. Now pay close attention to this. This right here has these right here, the plagioclases, all over the bottom, which I will show you in a second. And I know what they are from, and I know what this is as well. This is a toe. A left big toe. You say, oh, Roger, how could you tell that? Because it has this big callus on this big toe. And here's where those plagioclases are. You see all these little things here? You probably can't see them until you get it in a microscope, which I have up above. But you see all those? Well, probably not. You see all those little white spots? That's these little white spots right here. I think I got to get it in a microscope for you to see it. But that's the bottom of the toe. Now, you have one of these too. You have a little lump in the back of your toe. It's the hard spot where your toe sits down on. Now, this is the bottom of the toe. This is the callus. Look at that callus. That sucker is just, it's thick. And that's on the arterial side. This is where the artery side is. This is the actual toenail. And I think the guy had fungus. Now this right here, this black stuff, that's vein blood. That's not supposed to come out. The only reason that vein blood blew out of there was because it could not escape from the side that it normally would, which is the artery side, because it has a patch on it, which is the callus. Now right there, you see that spot right there? That's a tendon. There's another one over there, but it's wrapped up around this with the tunica that surrounded this. This one here hasn't eroded. That one eroded away. And we can see the tendons here. the same as this tendon right here. All right, and there's another one underneath here. You can't really see it, but it's right there. And the bone is in the middle. And that's a toe, my friends. All right, now don't forget, this is the toe, and that is the callus. That's how big this callus is. There's the toenail, and that is one of these tendons. And it's the black blood is not supposed to blow out of here. Black blood is supposed to stay in because it has valves. This was so much pressure trying to get out through that scab, that callus, that it had to blow out this way. The toe must have been down this way, and all the blood was running down. It had to go somewhere. So it either bubbled out of here and bubbled out through the black side. It just never happens, never, because the other arteries are just open. They just flow right on. But in this case, it was capped over so hard with that scale, callus, the blood couldn't get out. So that's why I know this is a left foot, and this is a big toe, and that's this callus on there. And the other side has that scruffy looking stuff on it that goes up against the next toe. It's kind of floppy looking skin, but it turned black because the black blood blew out through that side. Totally, almost never happens. Now we're going to be looking at a very small fingertip, and I'll show you what normally does happen with the blood, and I can show you how. Well, I'll show you. Okay, this is just too much. It's outrageous. On every one of your fingers and toes, you have an artery coming down which has the red blood, and then it webs over to the vein which draws it back. Now the vein have clamps, so every so often they have little valves. It can go this way, but it can't go back. They're like little flaps like this. The blood can go through, but when it comes back, it clamps off. It can't go back. Now, the toe I just showed you, the black side blew out. Never, ever happens. Now, let me show you how on each side there's going to be 2 holes here and 2 holes here, and then there's 2 holes at the end. And these are the artery side, and this is the vein side, let's say. Now, this is a fingertip, and it's flattened out. It was in the flood. This right here is the 2 blood side, the red artery side. And that also is the artery side right at the tip. Those blow right out. There's no obstructions. They just flow right out. These, you see that? That's the black side. That's where the vein blood would be. And same there. And then there's one right at the very tip here. It's hard to see. But you can see these quite easily. And that is a fingertip. And the red blood blew out the side and the end, and the black blood does not blow out because it has the valves. Now here's one that is very, very heavily eroded. Now if you're into anatomy, you will understand that is a pattern, that black pattern. I don't know if you can see it or not. But that black pattern is what's called bone black. And that is a distal phalanges. That's the pattern of a distal phalanges fingertip. And here's where the red blood blew out the side of here. You see it? And that's where the red blood would have come in, and it blew out here, here, and there. All right, just like it would here. This is it. This is extremely eroded. Now you can see, however, if you look, that black spot right there is a distal phalanges fingertip. And of course this side, you see it clamped off right there. Those are 2 clamps. And the same thing at the end, it clamped off right there. That's wide open because that's the artery side, artery side, artery side, artery side. Vein, you see there's the vein tube. It just clamps right off. They don't leak. All right, but that's a heavily, heavily eroded, obviously, fingertip. I have these things coming out of my ears, and I have 2 of them, giants, DNA tested. Hold on one second. All right, remember that flat looking fingertip I showed you? These are all the little plagioclases on it. All right, and I showed you, see all these little fibers? I think you can see that pretty well. Those are basically the same as you see over here. Well, here, hold on. Let's do it so you can see it better. All right, you see these? This is when I'm really down on top of that big fingertip. This is a different fingertip, this one here. But I'm going to move over to where the blood has oozed out. Remember I showed you how the red blood will ooze right out? There's some right there. And there's where the very tip of the fingertip was. All right, all that stuff there is red blood. You see it? That's the very tip of the fingertip that I showed you in those other spots. And that's where normally the red blood leaks right out. The black blood just doesn't leak out. All right, this is the vein side of that finger, that flat finger. And this is as much as you get out of there. It doesn't blow out. Now, the red blood just blows right out and leaks out all over the place. All right, now this is the red blood side. I'm going to put a little water on there, but that's where the red blood is just flushing right out of there. Now, usually a little bit of water will make things show up really, because they hydrate, they absorb water really quickly, usually. All right, let me crank up the... All right, but you can see that's literally blowing out of there, and they just leak all over the place. All right, that's the side, one of the sides. You see? And this is the very tip. It's hard to do this freehand, but the tip blows out the same way. You see it? Now I'm going to try, just for kicks, to see if we can get any catalase reaction out of this. I will have to come way down on it to get the reaction to see. But I'm going to put a little hydrogen peroxide. And we'll see, it should bubble off all over the place, but then it should stop bubbling in these areas, and it should continue to bubble here. And especially there should be like a white foamy foam around the blood vessel. Normally in that membrane around it, it gets a nice really foam. Let's see what happens. It may do nothing. I mean, this is pretty well eroded. This is this fingertip right here. All right, and what we're going to be looking at is that tip right at the end. All right, so there it is in the microscope. Now, let me put a little hydrogen peroxide, see what happens. All right, keep your eye on it. Here goes. Now, from way up here, we should probably see nothing at all because it's just too far away to see the little bubbles up here. But maybe we'll see something. It's hard to say. There's going to be little cavities where it should soak in and start to bubble up, I would think. But I could be wrong. If it's, yeah, I can see them right now. Now, I'm going to come we're way off of here. Whoops. Plus, I got a highlighted. Let's come way down, right onto it. Yep, see the bubbles? Takes a second to focus in here. Give me some time. Alright, you see the bubbling right there? Sometimes you gotta, I can get it only so close with this particular microscope. But now I'm seeing it starting to bubble up pretty good. You see it? Going right through that membrane. And that's something? That's catalase. Catalase is something that attacks extra oxygen within your bloodstream and in your membranes. That's a membrane right there. And it is attacking those invaders, which are the reactive oxygen species. It doesn't want these extra oxygens. Let me put a little more catalase on there, because it sucks it up. I'm sorry, hydrogen peroxide. It sucks it up pretty quick. The enzymes convert things very, very fast, and these are enzymes. Catalase is a very, very quick-acting enzyme. You see out here, there's nothing bubbling out there. There was probably some bubbling going on in originally, but there's nothing going on now. But we should find it's still going on in here. There it is, right there. This right here apparently was where the artery came out, and then this just is all leaked out over, and that's all hardened up blood. That doesn't appear to be that it's going to give off a lot of catalase reactions. You see, remember I told you the membranes? That's the membrane right there. And that's where the blood would have come right out, right in this area. I think you can see that, can't you? You see it bubbling out of there? And then you see that little line going across there? Let me see if I can focus in up there. Here, let me do this way. You see it? It's moving right down like it's pumping blood. You see that? That's where there's still got a lot of enzymes in that. It looks like it must be where the artery actually came in to service that tissue. You see it down here? How it's bubbling right out of that one spot a lot. And then it goes right down. Hold on, let me move this over. It goes right down the membrane. Remember I said to look for the membranes? And it gets kind of fuzzy. We're still far enough off, we really can't see how fuzzy it is. But you can see it's certainly working its way around here. And that's just a big pile of blood that's hardened up solid, and it's just too solid to have a catalase reaction. But the membranes have so much porosity to them. They're fluid-filled highways. So as soon as you put that catalase in there, the hydrogen peroxide, the membrane reacts. There's still a lot of vitality to this particular finger. Okay, watch this. This right here is those plagioclase little pieces. Remember you saw them out of there? This is on a fingertip. Now this right here, that's red blood. That's red blood that has run out of the tip of the finger. Now, just look at it and think about it for a second. All right, just pay a little close attention. That's the front of the fingertip, and it's just a normal fingertip. This is the fingernail right in this area here. Just like your fingernail. This right here is blood. Now what happened was this fingertip was tilted down this way, and all the blood ran down and had nowhere to go, and it will not go out the black side. It will go out the red side. The black side does not blow out. The red side blew out right at the very end. It didn't even blow out the sides. It just went right straight for the end. And that's where it came out the end. Now, if you can see, it's quite obviously the orientation that this was at. It was up tilted like this. Well, actually like this. And all the blood ran down and came out the very end and congealed right around the very end right here. That's all blood. You see, that's all blood until you get to the the actual finger plagioclase. But that's just like a big scab of blood that ran out from the artery. And only the artery sides run out. The vein sides do not. Normally. But the big one I showed you, it exploded out. See this? I believe that's a vein right there, and there's another vein right over here. I'm pretty sure that's the vein. Now on the other side, like I say, it blew out at the very end. So, you know, but these are the artery side, the reds. Anyway, it ran out at the end, and actually this is a crystal. You see that? It's like a garnet or something. All crystals is different types of blood in silicates. You see? That's where it all ran out right at the end right there. And this just happens to be growing a crystal at that particular spot. This stuff fascinates me. I can't help it. Once you start digging in, there's so much to understand. And you know, this is all about plagioclases and basalts. Geology is 100% wrong. 100%. Not 99.9, it's 100% wrong. All right, this is going to be wobbly. But this is the skin area, right at the very edge, and then you go inside into where the flesh is. You see it right there? That's the fleshy stuff. That right there is the artery. Hold on. Like I said, it's going to be kind of wobbly. But that really is the artery right there. All right, the red spot. I guess that's about the best I'm going to be able to do. But everything gets transitioned, but it gets a transition a little bit different. The skin, you can see quite obviously that it's from the outside there working its way in. And then this is all like tissue, body tissue. Now this is the side where the artery, vein is. It's right over in here somewhere. Like I say, the vein blocks off. You can't even hardly see it. But that's the artery. That one there is quite obvious. So if we go straight across, I believe that's the vein right there. And it's just turned to quartz, really. And up at the top, we had the bone up in this area somewhere. It's somewhere in there. But anyway, that's the fingertip. All right, I think I've made it pretty clear that these things are biological. They're not just rocks. They have all kinds of things going on in them. Now, this is, I mean, that's biology turned hard. Same thing here. This is that plagioclase basalt, which is nothing more than grip skin. This is fascia that coats lungs and so forth. This is just another bit of biology, some more here. This is all biology. This has a little bit of gold flecks in here. I forget where that was in the body. But if gold can accumulate anywhere, it depends on how the body was situated, because your blood is saturated with gold. Well, it's not saturated with gold, but there's gold in there, and then this is like going inside of a lung, I believe. That's just the outside coating of skin, and then you get into the inside. This is like shots of coal and bituminous things, which is nothing more than body fluids. That's nothing more than body fluids that's turned hard. Oh my God, these are, this is like coal. This is what turns into coal, is blood. These are all shots of different body parts. Look at that. That's all kind of a body cavity of some sort. I don't know what I'm sure it wasn't into a lung. I'm almost certain of that. And then this is the black blood. There's all body tissue. That, I believe, is a heart valve, or I'm not certain, but it has the look of the valve right there. And of course there's the round part, and then there's this right here. I remember I figured out what this was, but boy, I can't remember what I figured out. I mean, it goes on and on and on and on. I got so much stuff. Look at that. It depends. All of this stuff is the product of the Great Flood and being in this nucleophilic invasion. That's a lung. Those are alveoli. That's artery, which is open completely up and filled in with silicates, and that's the black blood that pinches off and just turns black. That's well, it's obviously an artery. The red means it's artery, and they evacuate, and then they fill in with the silicates. They call them vugs. And this is all this silicates. I have hearts here, and other things that are made out of just almost completely silicates. I have a heart here, it's just absolutely 100% silica. There's one little tiny spot of red. You see this? This is that basalt stuff. That's an artery. This, I think, is still fingerprints, and I think this is the grip skin that was over the top of whatever this finger was, or toe, or whatever it was. You see? I think this is the actual skin, and those are the fingerprints. That, I can't remember. That's some kind of gold. It's pretty red and bloody. Again, when you see that, usually that was an evacuated spot, and there's a hole there. It fills in with silicates, and the black never goes away because it's the tough stuff. This is the coating, which is the feldspar, which coats basalt. You see right there? Inside is the basalt. Oops, where'd you go? That thing scares me. Look at that thing. I don't know. I don't know what I remember seeing that thinking, holy smokes, that's a little scary. What that is, je ne sais pas. There it is again. Run for your life. I mean, I got some serious biology here. Sometimes I get a little worried, like that toe. I'm pretty sure that thing has fungus in it. You know, and I don't see any reason you couldn't get it today. See, there's those little things. Some of this stuff lasts. It seems like the biology lasts literally forever. I mean, there's still blood in these things. There's plenty of blood. There's blood on rocks, no problem. Anyway, I suppose that's enough. You know, I'm going to leave it at this, but basalt, all of these things that they claim they understand, these rocks and their formations, they don't understand any of it. This is gold coming out of here from little blood vessels. It depends on where the body was situated and how specific gravity works. Because every element in your body has a different, literally a different weight, and they separate it out according to these weights. So it depends on it. You know, there's so many different variations, but that gold, I believe, is starting to accumulate into these plagioclases because it will do its nucleophilic invasion based on where it is in the specific gravity field. And this area here is going to have some gold. A little further down might have silver. A little further down might have copper. But it's all when you get heavy, heavy, heavy transition metals. That's when you see these things accumulate. That's where metals come from. It's blood.